Guys, welcome to Swindim's online tutorials. On today's episode, we'll be discussing on applying Newton's second law of motion. Welcome back. Now, in this episode, we'll be specifying on the dynamics of particles. In this problem, we apply Newton's second law to bodies on which the net force is not zero. So that means these ones are not in equilibrium and hence they are accelerating. Now the net force is equal to the mass of the body times its acceleration. Let me give you this out in its vector form. In its vector form, it's something of this nature. Go to mass, this is in vector form. Now in its component form, it's going to be something of this nature. Like I said in the previous video, ax may. This is for the horizontal, this is for the vertical. So that is start for its component form. Let us solve some questions to understand more of this. So now we say that an ice boat is at rest on a perfectly frictionless horizontal surface. Now a wind is blowing along the direction of the runners, so that after 4 seconds, the ice boat is released. It attains a velocity of 6 meters per second. What constant horizontal force does the wind exert on the ice boat? The mass of the ice boat and the rider is 200 kilograms. So now our target variable is one of the forces, which is Fw, and that is the force that is that's exerted by the wind. So target, let me clean this. Target variable is what? Fw, the force of the force of the wind. So we need that force. So now in that case we are going to use Newton's second law. This law involves forces and acceleration. What we are being asked to look for is what? The acceleration of that boat. So now we will need to use Newton's second law of motion, and this law involves forces and acceleration, but the acceleration is not given. It's the acceleration now that we are looking for now in this case. We will need to find it since the wind is assumed to exert a constant force. The resulting acceleration is constant, and we'll be able to use one of the constant acceleration formula. Remember this formula now. When we say v is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as, and s is equal to u plus v multiplied by 2 over t. So now let us use one of them. Now what we are looking for is acceleration. Let me just draw a free body diagram of the ice boat and the rider. Now this is the force of the wind taking it this way. Now this is the mass. That is the normal reaction, and the acceleration is taking it towards the right. Now the force is acting on this body at its weight, the normal force exerted by the surface, and the horizontal force, which is our target variable. Now to find the x acceleration, note that we are told that the ice boat motion, so that it starts from s at rest, so that initial velocity is 0. So that means when we are told that this boat starts from x, so its initial velocity v over 3x is equal to 0, and it attains an x velocity of 6 meters per seconds after an elapsed time of t is equal to 4 seconds. Now we use this equation. Now this is the equation we're going to use. Vx is equal to Vox plus ax t. Remember this formula, v equals to u plus at. Now the three unknown quantities are acceleration, the normal force, and the horizontal force. These are the three unknown forces. This force, this is an unknown force, this is an unknown force, this is an unknown force. But what we want to get now is our acceleration. Let us get our acceleration first. But now our acceleration AX will be equal to Vx minus Vox multiplied by T, which is equal to what? 6 minus 0 over 4, which is equal to 1.5 meter per second. That's our acceleration. So we've gotten our acceleration to be what? 1.5 meter per second. Now let us get our FW. Now to find our FW, we first solve the constant acceleration equation for AX and then substitute it into the sum of forces equals ma. Since we've gotten our AX, all we have to do is multiply by our mass to get our. But now in this case, in the x direction, we have it to be W, so this will be W, and this is for this direction, which we have mass. Now the mass of the ice boat and the rider is equal to what? 200 what? Kilogram, and the AX is equal to 1.5, which is equal to 300 kilogram per meter per second squared. This is also equal to 300 Newton because it is force. Note that we do not need the sum of forces on the y direction at all to get our FW. We would need this equation if we wanted to find the normal force, but in this case we don't need it to find our normal force, but we can get our sum of forces on the y direction. Sum of forces on the y direction, which will be equal to n minus what? Mg equals to what? 0, because they must be. So our n is equal to what? Mg, which is equal to 200 multiplied by 9.81 meter per second, which is equal to 2.0 10 to the power 3 Newton. So we've gotten our normal reaction, we've gotten our acceleration, and we've also gotten our force acting on the x direction. So if you have a question, if you have something you want to ask, you have a problem that we think we can solve, you can drop that in the comment section. With that, I will be dropping the comprehension, and I'll also see you soonest. In the next video, we're going to be we'll be talking on apparent weight and apparent weightlessness. Goodbye.